Hi, good evening, everyone. How are you, Håkan?
Hello, I'm pretty fine. I'm really excited now because this is the premiere of our AI42. How are you?
And yes, and that's a really big word to say that we finally getting started
Yeah.
after all the work we did. And I
Yes.
really hope it will be very beneficial for everyone who is joining us.
Yeah. Yeah, I'm sure it will be. So,
So, just a technical information. Those who are watching us on Twitch, you are welcome to write your comments and questions in the chat because we are going to be able to answer these questions after the sessions and after the end of the stream.
yes. So maybe should we just get started?
Yeah, sure, I'm ready. So, do you know the technology behind how your face is getting recognized by your phone, or how Facebook knows exactly what to recommend for you to buy?
Or maybe you actually know the theory behind, but not the practice.
Would you be able to build those algorithms on your own?
Well, if you answered any of these questions with a no, then AI42 is here to help you because AI42 knows the answers to all your questions.
And before we got started about more about AI42, let us introduce ourselves. Håkan, could you tell us a few words?
Yes, so my name is Håkan Silverlager. I work with machine learning and big data for a Norwegian consultancy company called Miles. And I'm also interested in, artificial intelligence and Internet of Things, and I'm also quite involved in the local user group community here in Oslo. And I am a Microsoft AI MVP.
And I'm Eve Bardi. I'm also an AI MVP, working in full time at Avanade as a senior analyst, mostly working with artificial intelligence projects, but I'm also involved in different data science and data engineering exercises. In my free time, I go out and speak at different conferences and community events. I'm also writing a blog, which I'm going to share with you later on. And I like to help others. So if you have any questions or you want to have some support with your projects or something, feel free to reach out to me on Twitter or email or wherever you can. We'll talk about that later. So let's get back to AI42, because let's face it, it is quite hard to find the right materials on the internet to learn about these topics in a constructive way. But we are here to help you. So Håkan, could you tell us about the motivation of AI42?
But the motivation actually because comes from the fact that there is really no good starting material. So what we aim to do is we want to take you all the way from complete beginner to a phase where you have enough knowledge that you can start building your own models. So yes, come and join us and learn about all the current topics in AI and machine learning. And Eve, can you tell us a little bit more about the setup of AI42?
Sure. So AI42 is a strong team consisting of 2 Microsoft AI MVPs that strive to provide you with a valuable series of lectures that will help you to jumpstart your career in the fields of data science and AI. So Håkan, tell us a bit about our concept.
Yes, the concept is actually quite simple. So it involves professionals from everywhere around the globe. So there will be new content every second week on Wednesdays that will help you to understand both the underlying the mathematics and the statistics, probability calculations, together with data science and machine learning concepts like machine learning pipelines, for example. And with these lectures, you will be able to learn everything that you need to know in order to land your dream job, and as long as it's related to artificial intelligence and data science. So Eve, can you tell us more about the vision?
So you will be able to connect with the best in class experts from all around the world that will hold your lectures and workshops with rich content. And by creating cross collaboration with other organizations, we can give you the best opportunities to broaden your network in the AI and data science communities. With the combination of our offered services, we would be able to support less fortunate people and organizations that are not that recognized yet, even though they deserve it. So we are in close collaboration with the global AI community and Microsoft. So these lectures are going to be available on their YouTube, Twitch channel, and homepage, additionally to our own media.
Yeah, so follow us on YouTube, on Twitch, on Facebook, and on Twitter to become a part of this growing community where we will share knowledge and fun and find every information that will bring you to an advanced level. You will also be able to win Microsoft Azure badges and get vouchers for Microsoft certifications in return for your active performance.
So come and join us for free and be a part of a community that will help to be a trust towards AI in a responsible way.
So we hope to see you soon. So now that you know a little bit more about AI42, then it's actually time for our first presentation here. So that's Eve, that she will talk a little bit about how you can save more lives using data and AI.
So thank you, Håkan, for giving me the word. So let me talk about what I think is very important, how to save more lives with AI and data science. So in the last few years, AI has become more and more prevalent and powerful. Many speeches around AI nowadays explain how these technologies can be benefited to predict stock prices and create value for an organization. In fact, even the online courses that are meant to educate newcomers in the field are focusing on the financial benefits of AI. So, in today's materialistic world, I would like to focus on how the very same technologies can be benefited to predict natural disasters and eventually increase survival rates and improve quality of life. The disasters caused by natural phenomena have been present all along human history. Nevertheless, their consequences are greater each time. And this tendency will not be reverted in the coming years. On the contrary, it is expected that natural disasters will increase in number and intensity due to the global warming. And according to the world statistics, the increase in the number of world disasters between the decades of 1987, 1996, and 1997 to 2006 was 60%, going from 4,241 to 6,801, whereas the number of dead people during these periods increased 100%. And it went from more than 600,000 to more than 1.2 million. More than 9 million Australians have been impacted by a natural disaster or extreme weather event in the past 30 years. And the number of people affected annually is expected to grow as the intensity and in some areas the frequency of these events continues to grow. And these costs include significant and often long-term social impacts, including death and injury, as well as impacts on employment, education, community networks, health, and well-being. So humans have been trying to predict earthquakes at least since first century China, when they used this device, a vessel, fitted with metal dragons facing each compass direction like this. And if the ground shook somewhere in the region, the metal ball in the dragon's mouth would drop out, roughly indicating the direction of the earthquake. So I guess you can see such predictions actually sounded reasonable somewhere, but after some research, those things were concluded to be natural phenomena with little to no correlation to earthquakes. AI, however, relies solely on data. Multiple researchers are creating their own application to predict earthquakes and aftershocks. Moreover, these systems also monitor aging infrastructure. So AI can detect deformations in structures, which can be used to reduce the damage caused by collapsing buildings and bridges or subsiding roads. So during this talk, you will see a real life example of saving more lives with AI, how to examine a result of a natural disaster and how to use that observation to save more lives. Now, let me show you a story that motivated me to use AI to save more lives. In April 2015, there was an earthquake with 7.8 magnitude and an epicenter in the Gorkha district of Nepal. The disaster killed almost 9,000 people and injured 22,000. And this horror was in most cases caused by the collapsed buildings in the earthquake. Many data scientists have been working very hard to improve the survival rate of the next earthquake. Our mission is to build a predictive machine learning model to investigate and understand the risks of damage in case of another natural disaster. The result of our findings is available for mitigation of which buildings might need strengthening before the next earthquake. By this, not only memory of buildings and homes could be saved, but also thousands of lives. So we have been talking about data scientists, but what exactly data science means? It is really just an umbrella term, and it refers to figuring out how to study and solve problems with data. And to do that effectively, you need a range of skills like computer science, mathematics, statistics, and whatever domain you are in, you need expertise in that domain. For example, for this project, you might need to understand architecture and some kind of forecasting of natural disasters. So data scientists are absolutely obsessed with data. The first thing we always do if we have a problem to solve, that we're looking around for all the possible data sources which we can bring to bear on this problem. Then we have to figure out how do we acquire the data? How do we get it into some systems such as a data warehouse, Databricks, or maybe Azure Machine Learning Studio? But of course, the data is not always arriving in a shape what we hope for. So we might have to spend a lot of time on transformation, cleaning, reshaping, and so on. Then we need to understand the relationships in the data set, like what is the data trying to tell us about the problem we are trying to solve, and which of the features or variables actually seem to be useful, and which may just add noise to the situation. And then finally, we are going to do some predictive analytics or modeling, and through that, we hope to deliver value back to our customers or end users, which helps them drive decisions and make them better also. So what we want to do is to build a predictive model which is able to answer our questions by learning from the data we provide. And our big question now is, which buildings are in danger when another earthquake comes? Predictive analytics deal with designing statistical models or machine learning models that is able to predict. They are calibrated on past data, which we call features, and then they learn from these features, and then they are able to predict the future. And these futures are going to be our labels. There are several specific types of learning, but let me just tell you a few words about the most common ones: the classification, the regression, and anomaly detection. When the value is being predicted, for example, the car prices for next year, that is called regression. The approach that anomaly detection takes is to simply learn what normal activity looks like and identify anything that is significantly different. And when the data are being used to predict a category, it is also called classification. When there are only two choices, it is called two-class or binomial classification. And when there are more categories, then it is called multi-class classifications. And no worries, you don't have to remember everything what I'm talking about now, and you don't even need to totally understand what I'm showing today, because the aim of AI42 is to walk you through from the beginning to the end. So by the end of each session, you will be able to understand these things better and better. So we are going to use Azure Machine Learning Workspace, which is a fully managed cloud service, and it enables you to easily build, deploy, and share any machine learning solutions. But before we start working in the Azure Machine Learning Workspace, let me sketch you up the main steps that we are going to take while working with the predictive model. So first of all, we have to prepare the data. So we pull in the data into the system, which is Azure Machine Learning Workspace in our case, and then we have to prepare it for training. This can involve data cleaning, when, for example, excluding data that gives noise, some transformations, and then splitting. Splitting is not necessarily the basic meaning of splitting, but the idea is to prepare training and test data. So the training data will be used to train our machine, and the test data is used to validate whether that machine is working correctly. Then we also need to start the training. And in Azure Machine Learning, training a machine learning model starts with choosing which specific algorithm we want to configure our model with. And again, you don't need to fully understand the mathematics behind these models because you will learn all the details during the lectures of AI42. Then the next step is to score the model. Scoring is also called prediction in our case. And this is the process of generating values based on a trained machine learning model. And the generic term score is used rather than prediction because the scoring process can generate so many different types of values, like list of recommended items, numeric values, a predicted outcome, right? And so on, depending on what data you provide and how you train the model and what you want to achieve with this model. And then evaluation. And evaluation basically are metrics that tell you how good your model works. For example, the accuracy of a predictive model means that how well does it predict the future. So while working with a predictive model, keep in mind that it is not always working perfectly for the first try, and that you might have to apply some improvements on your dataset, your algorithms, and so on. But the best result is the aim, which is why machine learning itself is also an always improving field. This whole thing might sound like some kind of black magic, but thanks to the tools provided by Azure, you have the chance to easily get started with machine learning and learn about the different training algorithms, then understand what the results might tell you. So let me switch over to my demo, namely to Azure Machine Learning. And to reach Azure Machine Learning, you need an Azure subscription. So this is how it looks when you're logged in, and then you can create a machine learning workspace. And you just go machine learning, and then it's going to come it up, then say create, and then you define a resource group. I just define one that I have already created, then I give it a name that is possibly used already. But the idea is that you basically define a resource group and then a name, and that's all. So we just go back home because we don't need to create a new one right now because we have one already. And if you click on the one that is deployed already, you can just go to Launch Studio, and then the studio is starting up like this. So this is how the Azure Machine Learning look like. So this is the top level resource for all your machine learning resources, providing a centralized place to work with all the artifacts that you basically create when you're using the studio. And you can see that you can work with notebooks. You can basically write your code in this notebooks that is very familiar to those who has been working with Python before. It's exactly like the Jupyter notebooks. Then you can also use the automated machine learning that is used to automatically provide you the best working model for the specific data and situation that you are working with. And then you can use also the designer, which is the drag and drop interface where you can prepare the data, do some training, and then even deploy your models. And I don't want to go into very big details because there will be a session at AI42 that is about this studio in details. So I'm just going to show you one of the demo experiment I made. So what I want to show you here that this is a left panel, and maybe some of you has already used machine learning studio before, the classic, but this environment is very similar, but it has a lot of cool new stuff added, and the design is also refined, and it's really cool that it is like categorized into like this. This is really nice. So what we have to do first is to understand the data that we are going to use while building the predictive model. And the aim here is to see which values are useful features for us and which are the ones that are only giving noise to the observation. So let me show you our features. And this data comes from the Central Bureau of Statistics. And it contains information about different properties like the area, age, demographic data, and so on. And you can download it from my GitHub repo if you go to Exoblivione and the Nepal earthquakes. And yeah, so the other thing I wanted to show that are the labels we have. In the labels, you can see we have the damage grade here, which indicates how high is the risk of damage for the buildings in case of another earthquake. This can be 1, which is very low, and the 3 that is very high. And our model is going to predict the risk by learning from the experience data, which means that we are working with data that are either already collapsed or damaged in previous earthquakes. Then we can further investigate this column by looking at the statistics and visualizations, because you can see here the 3 different values in the damage grade and also the number of features for each of the categories. And the best case would be if these numbers were quite close to each other. So it is visible that number 2 has much more examples than the label 1 and 3. And this is a big problem, because if the model is trained on more examples with the label 2, it more often returns the label 2, even when the risk is supposed to be rather high or low. We shouldn't train the model on unbalanced data. So we are going to deal with this issue when we start the transformation and the preparation of the data before the training. So the field of statistics is often misunderstood, but it plays an essential role in our everyday lives, because statistics, if done correctly, allows us to extract knowledge from the complex and difficult real world. So what I want to show you is if we join these 2 data sets based on the building ID, I want to show you some statistics, some interesting stuff. For example, if I go and take a look at maybe this column, you can see that it's showing us how many missing values there are. And I have investigated all the columns, and I know that we don't have missing values in any of the columns, which is really cool, because otherwise it would give a lot of noise into our calculations and predictions. Another observation could be the has underscore columns, or every column that is starting with has underscore. It has a minimum of 0 and maximum of 1. And it could either be a categorical column or just a range between 0 to 1. But thanks to the unique values part of the statistics here, we are sure that there are only 2 values, which is 0 and 1. So this is categorical values, which we also want to change during our preparation of data. One more thing I wanted to show you, for example, these so again, these unique values and that how the values are placed like this. So we have like minimum 1, maximum 9, and there are 8 unique values. So that makes sense. But for example, in the age case, we can see that the mean is 25, but we have data from 0 to 995. And we can see also the difference that, okay, most of the buildings are between 0 and 200 years, which are very close to the mean, but there are outlier values with around 995 years, which are probably memorial buildings, actually. But instead of throwing out the outlier values, we are going to provide some normalization on the data, and then it is going to be ready to use. So let's, now that we have a good understanding of what data we are working in, and what are the fairly important data we want to look into, let's get it ready for training. So what I'm doing first is to select columns in dataset. And I'm not going to go into details, but the idea here is that I am throwing out some of the columns that I don't want to use, that are only giving noise into the situation. And then in the edit metadata section, I am going to define that it should be categorical, right, like this. And that was not a good idea that I did this, but yeah, so when I edit the metadata, I say that the has underscore column should be categorical, and the damage grade as well, because that is also categorical, right? Because we have 1, 2, and 3, so those are categories. So we can just change it to categorical. And then in the normalization, we're going to use the z-score transformation, and we are going to exclude the damage grade and the other categorical columns as well from normalization, because those shouldn't be normalized. Those should stay like how it is. All right, I'm going to submit this with the new update. I'm saying change categories, and let it run until I'm talking. So for now, we want to keep in mind that I was showing only the examples here, but remember I investigated all the columns, so I hope you sort of believe me with this. So, right, so after normalization and everything, um, I just wanted to show you one more thing, that what is actually z-score. So z-score uses the mean and the standard deviation for calculating each value. And it takes the value and decreases it with the mean of it, and then it divides it with the standard deviation of it. And after this, we will basically have like data in a range. So it will be closer to each other. It's important because imagine that the age is in years, the areas in square meters, so it's not the same kind of data. So it's a good idea to normalize it, so you're working with a prepared data set. So in data science, it is crucial to have the right quality of data to avoid biased outcomes, which would lead to unreliable models. So good data, or how I think about it, quality data, is defined differently based on the purpose and solution we want to support with the discussed data. For example, when I predict which buildings should be strengthened before an earthquake, the data needs to provide a real-world representation of these constructions. And to reach this condition, you need to apply extra transformation on the data. And because if the data is not prepared properly, then for this specific situation, we might end up predicting the risk of damage of these buildings wrong, which can cost human lives. And the challenge of working with imbalanced data in most machine learning techniques is ignored, and in turn have a poor performance. Although if you think about it, typically the performance of the minority class is also very important. And in our case, the high risk of damage is a minority class. And in the meantime, that's almost the most important information for us. So one approach to address imbalanced data sets is to oversample the minority class. And the simplest approach involves duplicating examples in the minority class, but that wouldn't add any new information to the model. Instead, new examples can be synthesized from the existing examples. So this approach is this SMOT. And what we want to do here is that splitting up the data. So I'm going to be able to compare the different classes. So I'm going to compare the 1 and the 2 to each other. And then the 1 is going to be grown by 400%. So it is getting closer to the 2. And on the other side, I'm comparing the 2 and the 3. And then the 3 is going to go a bit further up with 40%. And I'm also going to show you again how that data looked like before this smoother worked. And until our training is running, I'm just going to walk you through about the other steps as well. So this is how it looked like before doing this SMOT step. And what I expect is that the 1 damage grade should go up here, and the 3 one should also come up here, so they would be closer to each other. So we will have examples from all the categories in the same amount, and that is really useful and very important. All right, it's clearly going to work for a while, so let me continue. After doing the changes with the SMOT, we are going to put the data together and then prepare it for training. And how we do that, we are going to split it with 0.75, which is 75%, which means 75% of the data is going to be used for training, and the 25% of the data is going to be used for verification. And I really hope that you won't use this very often, this approach, because it's not the best approach to do. In our case, it is for the demo version of this the topic. It's okay. And then when the splitting is done, we are ready for training. And for this, we need to choose the best fitting algorithm. And you don't need to fully understand all the mathematical functions behind these algorithms, because Microsoft provides you the panel with the list of all the available algorithms. So let's think it through what algorithm we might want to use. And now I would like you to be a tiny bit interactive with me. So what I want to ask you that, do you remember, like we have what kind of labels? We have categorical labels, right? We have 1, 2, and 3. So Remember, we talked about classification and regression, and we could also choose clustering. But let's say I help you a bit. Which one is the better algorithm, the classification or the regression for this specific problem? And remember, we are talking about categories. So this is the classification algorithm that we are going to use. And also we talked about that if there are only two categories, then it is the two-class classification. And if there are more than two classes, then it's the multi-class classification. And if you're unsure what to use, because you don't, and again, this is the best way to learn how these algorithms are working and which is fitting you the best, that you can pull these in whatever you like, and then you also connect them here and you can compare them. For example, just like how I did in here. So I was comparing two algorithms here, and then I was training with both the algorithms, and then I compared them. So that's also an option. Right now, I decided next to the forest because that was the mostly good working for this specific data set that I'm using here. And so this multi-class decision forest, this is a classifier in Azure Machine Learning, consists of an ensemble of decision trees. And generally, these models provide better coverage and accuracy than single decision trees. But again, you will hear a lot about these algorithms later on in our other sessions. So after training, we also have to do the prediction and see how our model performs. And for that, you can use the score model module. And then after scoring, it will return us the probability. So which category is more possible to assign to that specific building, that will tell you in this scored model module. And it will also going to assign a category to that specific building. And instead of scrolling through like what building is assigned to what, you can review, and you should review the evaluation of the model. Remember, that tells you how good your machine is working. And if you go to evaluate model, then you can see it will return you the accuracy of the model. And the better the accuracy is, the result is, then it tells you that okay, your machine is working really well. But on the other hand, just the accuracy itself is not giving you the best information. So it is a good idea to do extra monitoring for this specific run, which again will be shown later on in sessions where it is a deeper introduction for Azure Machine Learning. So, and until this is running, I am just going to show it in the blog results. So this is how it looks like after the when you're looking at the evaluation. So it is going to give you the accuracy and some other information about your model that you can use up. And clearly, this model should be improved for a better accuracy. But when we are happy with the results, these information that we are resulting here in the scoring, so basically telling what building has a higher risk of damage and that building should be strengthened and all that, then these numbers can be given to people who can make decisions on which buildings might need to be strengthened. And with this documentation, we can deliver value back to help them drive good decisions, and based on that, save more lives. So during our AI42 sessions, we are going to show you how you can build, improve, deploy, and use your machine learning models, how the algorithms are working, and the logic behind data and AI solutions. And I hope before we log off, this will finish the run, and that I can show you the results of the scoring and evaluation. But I hope you still found this session inspiring, and I hope we will see you next year as well. And remember to follow us, and remember to look up the different extra information, some resources I show you here, some information about Azure Machine Learning, some pricing information, and my blog also, where you can find all my articles about this project. And you can follow that and try it out. And remember to follow us so you can get information when our next sessions going to happen. And yeah, thank you a lot for listening. I think Håkan is ready to talk. But before that, let me ask if there are any questions. Yes, so right now I can't see questions yet on my panel. So yeah, I really hope you found this session interesting. Now, something even cooler and magical is going to come, but I just checked back to my model if it is going better. No, not yet, but yeah, we will check back later. So, but before checking back to this, let me give the word to Håkan, who is going to talk about how to build machine learning in a browser using TensorFlow.js. And please give him a warm welcome. And Håkan, are you ready to take it away?
Yeah, so thank you so much, Eve, for your presentation here. So what I'm going to show you here today is how you can actually run machine learning directly in the browser using a framework called TensorFlow.js. But first of all, just to get everyone on the same page, I'm just going to give you some basic information on what is machine learning. So we have lots of different applications where we can use machine learning. One of them is, for example, prediction. So one classic example is that you have different neighborhoods with different houses, and then you want to be able to predict what will be the selling price of a new house. And that can be based on a number of different features. It can be on the location of the house, it can be on the number of bedrooms, for example, or when the house was built. You can also think about recommendation systems, like you've probably been experiencing when you bought something in a web shop, then it will recommend other purchases for you based on your historical purchases. And you can have clustering. Maybe you have a large amount of customers and you want to give them specified information. So then you can divide these customer groups into different types of clusters depending on what kind of similarities they have in that cluster. And we can also use it for image recognition, for text recognition, and for speech recognition. So one way that you can do machine learning is called supervised learning. So the idea here behind that is that you have access both to the historical input data and also the historical output data, what was the result. And then based on these two things, you can actually build a model. And you can train this model so that when it sees new data, then it can take this new data and then it can make either a prediction or a recommendation. So we're going to actually have a look at how can you build a system like this using TensorFlow.js. So let me switch over here to the browser. Or actually, we can first start here in Visual Studio Code. So here in Visual Studio Code, we have one HTML file. So in this HTML file, we only have a reference here to the TensorFlow library, and then we also have a reference to a component called the TensorFlow visualization component. And then we also have a reference here to a JavaScript file. So it's in this JavaScript file that all the machine learning will take place. And right now we're only logging out to the console just to make sure that we've loaded the script file. So if we go over back to our browser and then we run this, we can see that it writes out hello TensorFlow in the console. So then we know that it's working okay. But then the question is, we need to find some problem here where we think that machine learning could give us a good answer. So we have actually access here to some data regarding cars. So we have a JSON file here which describes both the name of different car and the miles per gallon and cylinders and the horsepower. So what we would like to find out here is, can we predict the miles per gallon depending on the horsepower? So first we would need to find out, is there any sort of relationship between miles per gallon and horsepower? So in order to do that, we need to be able to load this data into our JavaScript application, and then we need somehow to do a plot so that we can see, is there any type of relation between the miles per gallon and the horsepower? So what we're going to do first here is we're going to add a function here to our JavaScript file. And in this function, we will load our data. So let us go back here to Visual Studio Code. So in this function, what we do is we do a fetch on this cars data JSON file, and then after that we map out the data that we're interested in. So we're interested in the miles per gallon, and we're interested in the horsepower. And then we do some cleaning here, so we remove the null values from the data. We filter out these, and then we return the cleaned data. And then the next thing that we would like to do is we would like to be able to plot this data in order to see if there's any sort of relation between miles per gallon and horsepower. So let us define here a run function. So in the run function, the first thing that we do is we get our data, and then we map our data so that we get on the x-axis we will have horsepower, and then as y values we will have miles per gallon. And then we can actually make use of a pre-built function in this TensorFlow visualization component. So we can only call TensorFlow visualization dot render, and then what type of render we want to have. In this case, we want to have a scatter plot. So we want to plot horsepower versus miles per gallon. And then we will also add more code as this example evolve. And then we just add an event listener so we can listen to when the DOM content is loaded. Then we will run this run function. So let's save this and let us go back to the browser and let us run this. So now we can see here that without actually doing much coding at all, we actually got a pretty nice plot here. So we got the scatter plot where we have the miles per gallon here on the y-axis and the horsepower on the x-axis. And we can also see that there is some sort of relation because you can see that this follows some sort of a curve. So that means that this is a good problem for a machine learning algorithm, because if the data would have been scattered all around the plot, that would have meant that there is no relationship. So there is nothing for a machine learning algorithm to learn. So that would have been a bad candidate for machine learning. But right now you can see that there seems to be some sort of relationship, and then we can use machine learning to learn that relationship so that we can have new data and we can predict what will the new values be. So then what we want to be able to do here is we want to train a machine learning model where the input is one number, which is the horsepower, and then the prediction is also a number, which is the miles per gallon. So we will use these values that we have here, and then we will feed these values into a neural network. And this neural network will learn from these examples so that it can predict miles per gallon from horsepower. And this is an example of what we saw previously in my PowerPoint presentation, which I called supervised learning. The first thing that we want to do is we want to define what is called the model architecture. So basically that is what is the kind of algorithm should this machine learning model use in order to compute its answers. So in machine learning terms, these models are algorithms that they will take an input and then it will produce an output. And in this case, we will use a neural network. So the algorithm here will be a layer of neurons with different weights. These weights will decide what the output will be. And during the training process, this algorithm will learn the best values for these weights. And you will learn a lot more about this in coming sessions. But this is just an example just to show you what can be done. So let's go over to Visual Studio Code and let's add a function so that we can create our model. So in this function here, we create a modeler. We're using a pre-built functionality here in the TensorFlow library. So we create a TensorFlow sequential model. And this is one of the most simple models that we have in TensorFlow.js. So it's called sequential because the input flows straight down to its output. But there are also much more complex models where you can have multiple input and multiple output, and you can have different types of branches. So after we define the model, we need to add some layers here. So we add first an input layer to our model. And this is connected to what we call a dense layer. So dense layer is a type of layer that multiplies its input with a matrix. And then it adds a number that we call a bias to the result. So since this is the first layer of the network, we need to define the input shape, which is 1 in this case. So that means that we have one number as an input, and that's the horsepower of the car. And then we have units, that is how big will this matrix be in this layer. And here we set it to 1, so that means that there will be one weight for each of the input features of the data. And then we create an output layer where we set the units also to 1 because we want to have one number as the output. So in order for us to use this model, then we need to just create an instance of our model in our run function. So let me go back to the run function and here, so what we do here is we create the model, and then after that we are using some pre-built functionality again from the TensorFlow visualization component in order to show us a model summary. So we save this, and then we go back to the browser and we run this. So then if we scroll down here, then we can see here we get a summary of our model. So it says how many layers do we have and what is the output shape and how many parameters do we have and if it's trainable or not. So now when we have defined our model, then we would like to prepare the data so that we can train our model. So with TensorFlow, one important thing here is that the data that we use in order to train our model and the data that we use then when we make predictions all has to be in the format of a tensor. So the first thing that we need to do is we need to convert our car data to tensors. So let's define a function here where we can convert the data to tensors. So let's go back here and go up here. So here in this section here, what we do is we also do some best practice things. So the first thing is that we shuffle our data. And the reason why we shuffle our data is because when we train the data, we want to divide our data into batches. And then when we train, we want our batches to be as representative as possible of the whole data set. So that's why we would like to have data from all across the whole data distribution. So that's why we do this shuffling of the data. And it has also some other advantages that now we reduce the risk of just learning things where there is a dependency on the order of the input data. And we also reduce the risk to be more sensitive to structures in subgroups. For example, it could be that you have high horsepower for the first half of the training data, and that's a relationship that is not representative for the whole data set. And then we can see that the second thing that we do is we convert this to tensors. So we can use also a pre-built function, TensorFlow, Tensor2D, in order to transform our data into input tensor and the label tensor. So the label tensor is our output. And then we do a second best practice, which is to normalize the data. So what we do is we find the max and the mean value, and then we do some subtraction and division so that we get all the data will be in the range between 0 and 1. And this is something that is called mean-max scaling. And the reason why this is important is because many of the internal functions in machine learning models, they are designed to work best with numbers that are not so big. And then finally, if we scroll down here, finally we return our inputs and return our labels, and we also return this input max and input mean and so on. And the reason why we return this is because after we've done the predictions, we want to be able to scale back to the original scale. So then we need to have this so that we can sort of unnormalize our data. So so next up, now we've converted it to tensor, and then we would like to be able to train our model. So then we define a new function here, which is called train model. And what we do here is the first thing that we do is we need to compile our model before we can train it. And we also need to set some parameters for the compilation. So one of the parameters is the optimizer. So the optimizer is an algorithm that will decide the updates that the model as it sees new examples. So there are many types of optimizers available in TensorFlow.js. So here we've picked the Adam optimizer because it's quite effective in practice and it requires very little configuration. And then we also need to define a loss function. So the loss function is a function that will tell us how well is the model performing on each of the batches. So here we use something called the mean squared error to compare the predictions made by the model with the true values. Then next we pick a batch size and the number of epochs. So the batch size refers to the size of the data subsets. So it can range typically between 32 and 512. And in this case, we are setting it to 32. And then the number of epochs refers to how many times will our model look at the entire data set. So in this case, we have set it to 50, so that it means it will take 50 iterations to go through the data set. And then finally, we start our training loop by calling model.fit. And then also we can also use this TensorFlow visualization component again here. So we define a callback so that for each epoch we will have a plot here of the loss function and the mean squared error. So then it's actually time for us to do some training here. So then we need to add some code to our run function. So let us go back to the run function, which is over here. So what we do now is first we convert our data to tensors, and then after that we extract the input and the labels, and then we train our model. And then we just write out on the console that we're done training. Let's go back to the browser. So now if we scroll this thing down here, then we can see here that the result of our training. So we can see our mean squared error and our loss function here. And on the x-axis, you can see the epochs that we set to 50. And ideally, we want to have as low value as possible for this. And now we reach 50, so we can have a look at the loss function. So that's 0.04, for example. So let's say that we are happy now with our algorithm. So then the next thing that we would like to do is to actually make some predictions. So then we need to provide our machine learning model with some new data. So let's add a function here, which we called test model. And go back to Visual Studio Code. And so so what we do here is we generate some new examples here by also using a built-in function, TensorFlow linspace. So we generate 100 new examples that we can feed into our model. And then after that, all we need to do in order to get our prediction is just call model.predict on this new data. So then we will have our predictions. And then as maybe you remember that I said that we want to do an unnormalizing so that we can scale the data back to the original format here. So we do an unnormalizing using this input mean and label mean and so on. And then we just can return this unnormalized data. And then what we do after that is we are using this TensorFlow visualization component in order to make a scatter plot so that we can compare our model predictions with the original data. So so then the next thing that we need to do is we need to run this function. So let's me add some code here in our run function. So here we just call this test model function. And let us go back to the browser. And I should also say here that, this is just an example. So now we're doing this training all the time, but usually you don't really need to do that. But what is important is that you have some way that you can measure the training to see if it deviates a lot from previous runs, then you need to do some retraining here. And then we can see that, it does some sort of prediction here, but we can see that it's a straight line, so it's not exactly the way that we would like to have it, because this looks more like a curve to me, that the straight line is not the best is not the best prediction here. So then the question is here, could we actually do something in order to improve our model? So it's actually possible to improve it here. So let us go back to our script here, and then let's see where we define our model. Let me scroll up a little bit, up to here. So this is where we define our model. So let us comment this thing out. This, and let's uncomment this thing. So now we will add a little bit more complex model here. So we're still using this sequential model, but instead of just having an input layer and an output layer, we add two more layers. And in machine learning terms, we call this hidden layers. So with these hidden layers, we can also introduce non-linearity, which is a good thing if you have something which is actually not linear, as we could see. So let's see if this model will perform better than the previous one. So we just save this, and then we go back to the browser, and we run this. And we can also see that here our model summary also involves our new layers here that we were talking about. And there we can also see the number of parameters that we can train. And then we can also see that, this model seems to reach a much lower mean squared error and loss than the previous model. So it reaches much earlier after just 10 epochs, and it has a much lower, it's just 0.01 if you compare to what it was before. And then we can also see that it actually does a much better job at prediction these values here. So what I would like you to take away from this example here is that you can actually do machine learning here in the browser, and that we've used a lot of pre-built functionality in the TensorFlow.js library. And you can also, we did some rudimentary data EDA here to have a look at if we can see some correlations with our data. We could plot our model summary, and we could actually do training, and we could use all of this in the browser. So that said, I think that we will go back here to the studio.
Hi, Håkan. It was really exciting, this session, and thank you a lot. I hope others are also enjoyed it, because I think it was really nice to see. And I was looking around on the different social medias if there are some questions or comments, but I haven't seen real questions, only comments. So maybe we can just wait a bit. But otherwise, I think we just mentioned that we are available on Instagram, Twitter, and Facebook as well, which you can see on the screen. And feel free to follow us. That would be cool if you would follow us, because then you would hear about our next sessions that are coming in January.
Maybe should we say something about what will the content be in our first session?
Yeah, please go ahead.
Yeah, so in our first session, we will actually have a dive into mathematics. So we'll have Heine Ilmarin, she will give us 5 sessions here about mathematics so that you can actually get a much better understanding of the things that me and Eve showed you, and it will give you a very good foundation and basic so that you can take the next step in this interesting journey.
Yes, and it is as Håkan says, a journey, because we will start with baby steps to get to the point where you could be an AI engineer in the end.
Yes. Yeah, so I think with that said, we would like to thank all of you who are watching us real live, and we would also like to thank both our sponsor. We're sponsored by Microsoft, and we also got our intro music is composed by Mira Marie, and we have all the graphics that we have here on our show is developed by Levente Pongor. So with that said, we just wish you a nice evening and looking forward to seeing you in January.
On the 13th.
Yes. Have a nice evening.
Bye.